Okay, we have a car journey from Liverpool to Sheffield, but it's split into two parts, right? First part is from Liverpool to Manchester at 50, that's a distance of 56 kilometres, a speed of 70 kilometres per hour. And the second part is from Manchester to Sheffield, distance of 61 kilometres, time of 75 minutes, okay? And our task is to work out the average speed for the whole journey, okay? Now, firstly, let me say what you mustn't do, okay? We've been given the speed for the first part of the journey. We could work out the speed for the second part of the journey using the distance and the time there. So you've got the values of the two speeds, and then you just take those two numbers and work out the average, okay? Don't do that. That is not how to work out average speed for a whole journey that's split into two, okay? You can't just take the speed for the first bit and the speed for the second bit and work out the average, okay? Don't do that. It doesn't work. What you have to do is work out the total distance and the total time, okay? That's how you work out average speed. So I'll write that down. The formula is average speed for the whole journey, okay, is total distance over total time, right? Commit that to memory right now. That's the only way to work out the average speed for the whole journey, okay? There are no shortcuts. Don't fall into the trap of just working out the average of the two speeds. Okay, so let's do it. We need to know total distance. Well, that's easy. It's just 56 plus 61, okay? 56 plus 61. And that's in kilometres, okay? I'm going to include the units. Kilometres. Right, over total time. Well, we know the time for this journey from Manchester to Sheffield, or that part of the whole journey. We need to work out the time for this bit, okay? So, for this bit, the time is distance over speed. That's just using speed as distance over time. Speed is distance over time. It's a general formula connecting speed, distance, and time. However, you can also work out what to do just by looking at the units, okay? You've got 56 kilometres and 70 kilometres per hour. Just by looking at the units, I know that if we divide them, kilometres on the top, kilometres on the bottom, they cancel, okay? And when you divide and divide again by something, that's the same as that thing being on the top. So the answer to work out the time is just 56 kilometres divided by 70 kilometres per hour. And that will give us something in units of hours. So that's the time. And 56 divided by 70 is 0.8 hours. Okay? So that's, I'll write it on this side, 0.8 hours. Good. Okay. Now, to work out the average speed, we don't want to give the units in kilometres per minute. That's a silly unit. We want kilometres per hour. So I'm going to leave that in units of hours rather than convert it to minutes. And I'm going to convert 75 minutes into hours. Okay? So 75 minutes is, well, 60 minutes is 1 hour. So that's 1 hour and 15 minutes. Okay. But we've still got more work to do. We need to 1 point something. So 15 minutes is a quarter of 1 hour. In other words, 0.25 of an hour. So therefore 75 minutes is 1.25 hours. Okay? I should be consistent. I'll just remove that R. We're just going to use H for hours instead of HR. Good. Okay. So total time is 0.8 hours, 0.8 plus 1.25 hours. Okay. And the units are correct. Kilometers per hour. That's the speed. So stick that in your calculator and you get 57.07. 57.07 kilometers per hour. Are we going to leave it like that? Let's go to 1 decimal place. That just feels a bit more sensible for this question. Okay, so that's 57.1 kilometers per hour to 1 decimal place. And that's how you should present your answer. Write 1 dp in brackets. Okay, so that's it. That is the average speed for the whole journey. Right, next bit. Janie drives from Barnsley to York. Now, she goes from Barnsley to Leeds at 80 kilometers per hour. Okay, and Leeds to York at 60 kilometers per hour. Janie says that the average speed from Barnsley to York, so that's overall, for the overall journey, okay, Barnsley to Leeds and then Leeds to York. So she's saying that the average speed for the whole journey can be found by working out the mean of these two speeds. The mean of 80 and 60, in other words, 70. Okay, and I've been saying that's exactly what you shouldn't do, and that's wrong. And it is wrong. If Janie is correct, what does this tell you about the two parts of Janie's journey? Okay. If you do it the wrong way by working out the average of these two speeds, there's one situation by sheer fluke where you can just happen to get the right answer, okay? You should still always do it like this. But that situation is when the time spent for both of these two different legs of the journey is the same. So in other words, by taking the average of 80 and 60 to get 70 kilometers per hour, that would only be correct if the time spent driving from Barnsley to Leeds is the same as the time spent driving from Leeds to York. Okay? And because you're driving faster for the same length of time going from Barnsley to Leeds, it means the distance from Barnsley to Leeds must be greater than the distance from Leeds to York. Because if you're spending the same amount of time on these two legs and you're going more slowly for this one, it must mean that that distance is shorter than that one. Okay? So write that explanation for your answer. It's only a 1-mark question to finish this question off, and that will get you the marks. Okay, so at this point, the question's done. It's over. We've got our full marks. However, I'm going to prove to you why this is the case. Okay? Right. So, again, I want to stress that the question is over. This is extra for your understanding. Okay. Right, so we'll do it like this. The average speed, again, is total distance over total time. Right, so she's got lucky and just happened to get it right by taking the average of 1860 to get 70. So, total distance, let's say that's a distance of X kilometres, okay, and Leeds to York is Y kilometres. So, total distance is X plus Y, okay, and total time, right, the time for this leg, time is distance over speed. So the distance is X and the speed is 80, okay? So time for this leg, time is distance over speed, distance is Y, and the speed is 60, okay? And she's just happened to get this right, the average speed is 70, right? So this is the situation when this just happens to work out. So that's the equation. Okay, so from here, let's bring the 70 down to this side and all this up here. So we get X over 80 plus Y over 60 is equal to X over 70 plus Y over 70. Okay? In other words, I've multiplied both sides by that. I've brought all that lot up here. I've divided both sides by 70. Okay? Let's get rid of those zeros by multiplying everything by 10. Now let's multiply everything by 8. So we get X plus 8Y over 6 equals 8X over 7 plus 8Y over 7. Let's multiply everything by 6. So we get 6X plus 8Y equals 48X over 7 plus 48Y over 7. Let's multiply everything by 7. So we get 42X plus 56Y is equal to 48X plus 48Y. Good. So subtract 42X on both sides and we get 6X on that side and hang on, something. What did I do there? 56Y, okay. Subtract 48Y from both sides and we get 8Y. Okay, so in other words, Y is 6X over 8 or 3/4 of X. Okay, so it's correct. As I said, Y, the distance from Leeds to York, is less than distance from Barnsley to Leeds. Okay? It's actually 3/4. And again, I don't want to stress, this is just a proof. Okay? You don't need to do all of this for that measly 1 mark for this exam question. This is extra for your understanding. Okay? So we've proven it. In the one situation where taking the average of these two is correct, it only works out if the distance for the slower journey is smaller than the distance for the faster leg of the journey. or if you like, you can write it x is 4/3 of y. So x is bigger than y. Good. Okay. I'm going to keep going. Again, this is extra. I want to do an example to show you why you have to do average speed as total distance over total time. Okay, let's get rid of this last bit. To show you why that is exceptional, okay? That taking the average of the two speeds only works when one distance is an exact ratio of the other distance, okay? I'm going to show you why you have to always use this formula to make sure you get the answer correct. So, let's take a journey. We're going from A to B to C, okay? The A to B leg is 20 kilometers per hour. That's the slow leg. The fast leg will do it at 40 kilometers per hour. Now the two distances are the same, okay? Both 20 kilometers. Right, so this is a typical way they might present an exam question to you, okay? You're going from A to B, it's a distance of 20 kilometers, you're going at 20 kilometers per hour, then you go from B to C, it's the same distance as from A to B, it's also 20 kilometers, but you're going at 40 kilometers per hour, twice as fast. What's the average speed? It is not 30 kilometers per hour, okay? Once again, I'm stressing you can't just take the average of these two speeds, okay? It's not 30 kilometers per hour, and I'm going to prove it to you mathematically, okay? The reason it's not 30 is A to B is the same distance as B to C, which means because you're traveling faster for this leg, you're spending much less time at that speed, which means the average speed will be closer to that. It'll be less than 30. Okay, so let's do it. Right, we've got speed, distance, so time. Time is distance over speed. So time is the distance, so 20 kilometers over the speed, 20 kilometers per hour. And as promised, if you include the units, you can see why that's true. Kilometers cancel. Divide and divide again by something is the same as it being on the top. So that's 20 over 20 hours, which is 1 hour. Okay? So 1 hour to get from A to B. 1 hour. Right. For this leg, time is distance over speed. So 20 kilometers over speed of 40 kilometers per hour. Boom, boom. That's on the top. So time is 20 over 40 is half an hour. Okay? So that's half an hour. Right, same distance, travelling twice as fast. You're going to spend half the amount of time, right? Good. So, like I said, you're spending twice as much time at 20 kilometers per hour than you are at 40. So that's why the average speed is going to be closer to 20. So let's work it out. Average speed is total distance. So that's 20 plus 20 kilometers over the total time. 1 plus half hours, which is 40 kilometers per 1.5 hours, which is, stick that in your calculator and you get 26.6 recurring, so 26.7 kilometers per hour. So, can you see? That is why, by doing the actual maths, the average speed for the whole journey is closer to 20 than it is to 40. You see, it's not 30. Okay, it's less than 30. For the final time, I'll say it again, because same distance, you're spending more time at the slower speed. You're spending twice as much time at the slower speed than you are at the faster speed. So the overall average speed will be closer to the slower speed. It's less than 30. It is closer to 20 than it is to 40. Brilliant. Okay, that is more than enough. So learn average speed is total distance over total time. There we go. Thank you for watching. I hope you found this video helpful. If you did, please click the like button, and it would be a massive help if you could subscribe. It would also be amazing if you could support me on Patreon. All the papers and everything are on my website, drgem.com, and I'm also on social media. Thank you.